Hello guys, it's Kamil, and this time we would like to cover arrays, which is the second primitive compound data type in Rust. And actually this one is of a fixed length size, which is similar to tuple, so you cannot change its size after its declaration point. And actually also it can only contain the values of the same data type. So unlike tuples, tuples could contain different data types. Let's create a little project here and let me show you how you could use these arrays, how you could declare them. Let's start off with some simple example. So if you create a let statement, and yes, we'll do immutable with this particular example, you can declare an array using square bracket notation, putting the values inside and separate them by commas, and the Rust will be able to infer this type. And like I said, they have to be of the same data type. And actually this will work. If I show you this, cargo run, it will build and run. As you see, there is no issue. If I'll, for example, do this, then I expect for it to work. Looks Rust can actually infer if you provide that. But if I do it this way, that will fail, as you can see. So if you provide this explicit even in the middle, then Rust will know that all of them must be the same. If you will provide two different data types, the Rust will fail. And it will take the first explicit notation, like here, and it will assume that everything else must be of this same type, which is not in this case. So yeah, let's remove this because we don't want to have this issue going forward. Let me show you how you can annotate arrays. So to annotate an array, you open square brackets, you provide a type you expect to have, and you provide the length that you expect to have as well of this array. And now you can provide your values as you know, as in the previous example. And now if I run, I expect it for it to work. And yes, it does. The other way you can do it, for example, sometimes you may have a situation where you would like to simply create an array and initialize it to some values, like let's say 10 zeros. You can do that too. You provide first the value you would like to initialize it to, and then the count. So let's say the length of the array. So this will create us an array that will contain 10 I32 integers with the value of 0, like this, simply. And now let me show you how you can also access array elements. So let's create one. Let's make this mutable, so I'll show you also how you can modify them. So L, and let's have, and I know it will be I32, so we can even do the explicit type annotation to show you. And I'll get the last element of it, and I will print this out so you can have a look that it should work and print us the value we need. And as you can see, it works out. Now, let's actually modify the element. So to access the array element, I have used square notation, which may not be new to you if you have used other programming languages like Python and you were accessing list elements, you would have used square brackets. So now let's actually go and get another element. Let's actually overshadow that one there above, that one above, and I will not use annotation now. Actually, sorry, what I'm talking about. I will just modify first, right? So R3. Let's modify this last element and let me pretty much stick something else to it. So number 4 maybe. And now what I can do, you already know how we can access it. So that's what we'll do. We'll simply just access that 10th element. Just like this. I will not be creating another variable this time. And what I would expect to see is number 4. And yes, we get number 4. This one, of course, wouldn't change. It's immutable. We give that warranty to our users that if it's been declared as a mutable, it will not be changed, okay? And it's been also defined beforehand, so it has its own copy of the value. And we'll come back to this before long in ownership videos and stuff, but this is not the time for it. So yeah, just a quick intro. Now let me show you how you can print the whole thing. You might think that this should work, and you probably would be right in plenty of languages, but in Rust it actually does not work. Why? It's because Rust doesn't know how to format. It cannot just infer from this syntax, uh, because what it requires to be able to display it, it requires a display trait to be implemented on this type, and it is not implemented. So if you would like to really print it, and the traits are something that we'll come back to in the future, then if you'd like to implement it, then you need, or display it, you should tell the Rust explicitly what you want. If you would like to have something that will put everything like on the one line, this is the option for you. If you would like to have it pretty printed, which will be across multiple lines, you can use this syntax. Let me show you how it works. So if I would like to print this on one line, I would use that question mark after the colon. And as you can see, I could copy this from here actually and paste it here anyway as well. That should just work fine, and it would look quite pretty as you would normally define it yourself. Now, if I would like to have it on like pretty printed, I can do that. So Rust will pretty print it for me, provide indentation for different levels and each value on each line. As you can see, you may like it or not, but this is the way that you can print these arrays or compound types, which also involves or includes the tuple, right? So I've not mentioned that in the previous video, but yes, it's also appropriate stuff to do with tuples. Otherwise, you will get the same error. So that's that. There's one more thing I wanted to cover with arrays, for example, is that what will happen if you will try to access an element that does not exist. So as we know, R1 has only got 3 elements, right? So if we try to, what will happen if we try to access not the fourth one, let's take the fifth one. I will not even print it, I'll just do that. And let's now try to do the cargo run. We'll get an index out of bounds that is being thrown at the runtime, as you can see. And now this is a great thing because Rust actually safeguards it from accessing invalid memory or memory we shouldn't have access to, which could lead to undefined behavior, right? Like reading some arbitrary data, which we don't want to do or allow for. And it's quite explicit information here what it does. It should be quite clear to read for you if you're a programmer, but you can look at it. So if the length is free, right, but we're trying to access an index 4, which means a fifth element, because Rust, like a lot of other languages, is indexing starting from 0. So if you have a first element, it will be 0. If you have the last element, it will be length minus 1. So in this case, our last element will be at the index of 2 because we have 3 elements. But this is actually 4, so it's the fifth index, which we don't have. And that's why we are failing. And that is great because Rust is safeguarding us and preventing us from accessing something we shouldn't. Now, why is it happening at the runtime? The reason is that you may allow the user to provide you some input with an index for an array. And actually you pretty much, this could be completely valid, right? So the compiler will allow to compile, but it will just add an extra check during the runtime. So that if the user provides you something that is outside of what we expect to have, so out of bounds, then you will get this panic and nothing bad should happen, right? So that is how Rust is trying to safeguard you, at least one of the ways of how it does it. Okay, maybe I've not also mentioned that arrays are actually stored on the stack, which I believe is also the case with tuples, but that should cover the arrays. You can also look into the book for all of these data types we've covered over the last 4 videos. And that's where I'll wrap it up actually. Because we have covered, I think we've covered all of these scalar types and compound types that are just primitive or primitive scalar types and compound types. So we can just go ahead now to the functions in the next video and we can complete this one. So bye bye and thank you for listening.